United States citizens are among the highest ranking populations in the prevalence of elevated stress levels, which is strongly correlated with sleep deprivation. These problems are not limited to the working adult. In a study conducted by the American Psychological Association, over 1/3 of teens reported stress-associated outcomes such as sleep loss, trouble concentrating, and feeling sluggish. In order to better understand the impact of these psychological stressors, this study aimed to assess the relationship between stress levels, sleep duration, and cognitive functioning. This study implemented the use of a combination of online self-report measures and experiments to gather data. The survey began with several demographic questions regarding age, gender, and education level. In order to assess participant stress levels, an existing survey known as the Perceived Stress Scale was used, which includes 14 Likert-style questions addressing overall mental health. Sleep duration was recorded using self-report measures of nightly sleep, in addition to 2 supplementary multiple-choice questions assessing how participants' quality of sleep impacted daily activities and productivity. In the experiment portion of the survey, cognitive functioning was operationalized through assessments of participant reaction time and response inhibition. This was done using a previously established experiment known as the Go, No-Go task, which prompts users to physically respond to visual stimuli as quickly and accurately as possible. Participants were required to react to a randomized order of 2 different images, either a go or a no-go stimulus. In the case of a go stimulus, participants were instructed to press the spacebar as quickly as possible, whereas a no-go stimulus instructed participants to refrain from pressing anything until the next stimulus was pressed. Similarly, response inhibition was measured based on participants' error status. Responding appropriately resulted in an error score of 0, and reacting in a manner that opposed a respective visual stimulus, such as pressing the spacebar when instructed not to, resulted in an error score of 1. This exercise was repeated for a total of 25 randomized exposures, at which point participants' average reaction time and summed error values were recorded. Higher values in both categories were tied to slower reaction times and less response inhibition, which can be associated with decreased cognitive functioning. A linear regression model was used to determine if there was a relationship between self-reported sleep duration, stress levels, and reaction time. However, there was no collective significant effect. While this study did not show a significant relationship between sleep, stress, and cognitive functioning, that does not necessarily mean that a relationship doesn't exist. One possible reason for inconclusive evidence is that the standard deviation of participants' sleep duration was only about an hour and a half, so more distributed data would likely help demonstrate a significant effect. Previous studies, such as the APA study on teens' experiences with sleep, stress, and daytime dysfunction, show that there is a likely correlation, but further research is needed to be sure.